And now I would like to call upon Digvijay Sharma, Senior Director Sales, Ciena Communications India, for the industry keynote on It's Time We Recognize India's 5G Dream with Make in India. Sales leader with a proven track record of creating new accounts and growing them in one of the most competitive markets in the world. Excellent understanding of the market, solid skills in sales, business development, solution designing, and positioning, building strong result oriented teams, and yielding results on multi product and multi time zone environments. We welcome you on stage, Digvijay Sharma. Over to you, sir.
Hi, I'm Digvijay Sharma, Senior Director Sales at Ciena India. Thank you, Voice&Data, for giving us this platform to share our thoughts. Today, I'm going to talk about India's dream of 5G and Make in India, and how both of them put together synergize to make India digital India dream into reality. With that, I have few slides that I would like to share with the audience, so that I can express my thoughts in more cohesive way. So as I said, today I'm going to talk about 5G dream with Make in India. First, I will start with 5G and what are the challenges that it throws on to service providers, and how it is better from the previous technologies, and how Make in India and Ciena is going to solve these problems for our service providers and overall market. As I said, 5G is one of the most promising technology. It provides connectivity anywhere at any time to anyone on and to anything. There are three key cornerstones of 5G. One is enhanced mobile broadband, which talks about very large, very high capacities up to 10 gig per subscriber. And second aspect, MTC, which is massive machine type communication, which talks about scale, and ultra low latency, which is about the latency, as it clearly says. Now, all these things put together gives wide variety of solutions to the industry, and this helps to solve many use cases, whether it is telemedicine, whether it is high-speed train, driverless cars, and whether it is to agriculture or many other services. All these things put together give a clearly new driving engine to Industry 4.0, Edge Cloud, as well as industrial IoT. With that, there is a clear-cut case that is coming up of private 5G, in which intelligent solutions are coming up, and complete industry is very much excited about it. Just because 5G gives so many, it's such a better technology and has got many advantages over existing technologies like 4G and Wi-Fi. With that, I'll try to capture the key trends, and in those we will talk about what is the key things that we need in 5G, their consequences and their impact on technology and to the service providers, and what kind of different solutions that would be needed in order to meet those objectives. First of them is that 5G requires more radio. It is because that we need more bandwidth and lesser latency. This leads to a technological impact from today's DRAN, distributed radio network architecture, to move towards CRAN. And this further leads to a requirement of mid-haul, front haul, and cloud RAN. I'll explain these things in a bit of more detail in subsequent slides. And since the network is scaling to much bigger architecture, much larger number of radios, we need more simplified network architecture. And with that, segment routing becomes a key requirement. Another key aspect about is that when investors are going to invest in such a large infrastructure, they need to monetize their network. For monetizing, broadly, there are two different kind of things. One is the existing wholesale offerings, which would require multi-tenant support, leading to a technical solution, which is Flexi, and then differentiated services to different industries. Like some industry would require low latency, some industries would require very high capacity, some industries would like many connected devices. With these different industry requirement, differentiated services would be offered. For that, network slicing becomes a key requirement. On 5G, use cases drive network impacts. So the bandwidth increases, and the requirement of latency are far more stringent than any other of its predecessor technology. With high binary increase, current 1 gig connectivities in the network would go to 10 gig, 25 gig, all the way up to 100 gig in some cases. In North America, most of the service providers are even today deploying their network with readiness of 100 gig capacities from GNB, the radio. And the latency will lead to edge compute, which is generating edge cloud infrastructures as well as time sensitive networks. These are the key trends and their technological impacts both on the service provider and a broader technology domain. I'll just focus on first as technological aspect, that is spectrum and radio densification. As you know, 5G is about higher capacities. Higher capacities means higher throughput and more bandwidth, which means we need more capacity, we need broader spectrum, we need more higher spectrum as we would carrying more data. When we go higher into spectrum, as shown into this chart, then what happens that the propagation becomes restricted, and that leads to a requirement of more cell sites, which means more radios getting into the equation. With, let's say, this is an existing 4G scenario. In 4G and 5G, we first, as these technologies would be rolled out in phases, the first enablement of 5G would give 5G on the existing footprint, on the existing spectrums of 4G. With that, we will have 5G coverage, but will not have the higher bandwidth. In order to further increase the bandwidth, we will need more higher bands of spectrum, which will lead to more radios. And as you can see, the coverage of these higher spectrum is lesser. When we talk about even further densification of radio, when we are talking about more real, more useful, more advanced 5G use cases, the densification of radio is going to increase. So this diagram clearly tells you how much more equipment and how many more radios would be needed in order to realize the 5G dream. So this has a clear-cut impact onto the network loads. In order to simplify those network loads, there are newer technology in the networks that are coming about. So how do we solve this thing is captured in these slides. With more radios coming in, as you can imagine, more complexity is coming in, and hence, plus the cost is also increasing. So the question comes up, how do we better scale the RAN? How do we reduce the cost and complexity? So that is being done by moving from CRAN to the from distributed RAN to the cloud RAN. Basically, what we do is that we split the radios into a more scalable model, which is more efficient both in terms of capex and opex, which means space and power, in which we split the radio head from the cell site. The BBU is moved out from cell site in terms of CU and DU, and the RAN becomes centralized rather than a distributed RAN. So on each of the towers that we have today, we have a BBU down below. In centralized RAN, the RRH would be separate and DU and CU would be separate. This reduced into lot of cost reduction as well as and adds to the network simplicity. And this is how going forward the next generation architectures would be. As I said, we need more radios, and for more radios, we need to move away from DRAN and move to CRAN. As in previous slide I shared, the BBU would be moving away from the radio site and would be moving to a more central site. These architecture are today's architecture, in which we have in all the current deployments, we have a mobile backhaul network in which there are access site and aggregation site and then the core sites. Now the network architecture deployment models on site on fiber are going to remain more or less the same. The only densification would increase, and network level, some simplifications would come, like BBU would move from radio sites to a more central site. And this is further divided into DU and CU, distributed unit as well as centralized unit. This would further move ahead and would become virtualized in nature rather than physical components there. It would be done on x86 compute, which would be a standard virtualized software would be there on a general purpose compute resources. This will make the networks more cloud RAN, and you will see more principles like edge cloud coming into play into the actual RAN networks. So this architecture would be done in various variants because vendors technology shifts don't happen overnight. This is the desired architecture, but we would be moving most of the service providers would be moving in a phased wise manner, in which there would be multiple different architectures would be there depending upon the cost depending upon the cost, as well as the infrastructure availability, as well as the spectrum availability. Depending upon that, multiple of these architectures would be adopted by the service provider. Now, since there would be multiple different architecture, there would be different transport requirements that would be coming up, and service provider will have to choose a transport which not only caters to all these different requirements, but also is futuristic in nature. And what they invest today, they should be able to utilize the same network infrastructure when they reach their desired state of completely virtualized distributed RAN architecture. In order to meet these requirements, Ciena has a wide variety of product portfolio. To talk about XOL families, these solutions can work in any RAN and are agnostic to various RAN vendors. They support variety of front haul options and have adaptive IP capabilities and support different type of speeds and feeds, which help them cover wide variety of capacity, latency, as well as network deployment requirements. Ciena has 15 years of experience in country. We have over 2,000 employees in India, which shows and 1,200 about 1,200 R&D resources, which shows we have a strong presence in India and we understand the geography pretty well. We have presence in all the tier one service providers like Airtel, Jio, Vodafone, and all the key enterprise service providers. This helps us to understand the geography as well as the local India requirements in much better manner. Now, Ciena is going to come up with Make in India. Now, together with local R&D and geographic expertise and local manufacturing capabilities, we would be able to serve our service providers and help them build 5G networks in more effective manner. Not only that, we will also be able to make an India dream a reality. Ciena will manufacture select routing and switching portfolio products to support 5G use cases in India. This will not only be focused on India, but also some nearby geographies. We have local demo labs which can validate the products that we are going to offer to customers before they are implemented in network. With this, we would be able to help the Indian service providers to make their will help them realize their 5G dream. Thank you, Voice and Data, for giving us time today and share our strategy about 5G and Make in India.
Thank you, Digvijay, for such a wonderful presentation.